The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. My name is Kevin Vogel. Welcome to the webinar today. I think we have a pretty exciting topic with converged architecture and a hot topic in our industry. We're lucky enough to have Andy Stokes with us, who's the Enterprise Product Specialist with Cisco for Hyper-converged. How you doing, Andy?
Doing well. Thanks so much for having me on the call today.
That's great. So just a little background here. We're using live meeting today. We're using go to my webinar, and you'll see on the right-hand side of your screen you can ask questions, and there's also a chat box. We'll be monitoring that all along the way. So if you have questions for Andy or any of our other panelists, while we walk through the presentation, please ask them. We'll try to cover them as they come up, or worst case, at the end of the webinar. So let's get started. So first of all, my name is Kevin Vogel. I'm the Vice President of Virtualization and Cloud here at Champion Solutions Group. 5-minute or not even a 5-minute commercial here on Champion and who we are. We really specialize in 5 areas, and I think you'll see that Hyperconverged fits into a lot of these areas. Mobility, hot topic out there. Everyone on the planet carries a device, and now people have to secure them. So mobility is a big part of what we do for our customers. Cloud, and both private and public cloud, and obviously Hyperconverged, a huge part of the private cloud environment. Security, and this is the hottest thing in our industry today. Everyone has some type of compliance or regulatory requirements that they have to meet, and Champion has a really dynamic security staff and security practice that we've worked on for years to help our customers. Data management and analytics is really our bread and butter. It's where we come from. We've been a large storage and data management company for well over 20 years, and being established in 1979, there wasn't a lot of data out there, but nowadays storage is still the number one product out there that people are actually using. And then services and consulting. If you can install and help manage and service what you do, you're not really a lot of value to your customers. This is just what our partners say about us and the industry says about us. Obviously, being a big Cisco partner, being a premier partner, certified in their server platform, and have been for the last 5 years. We were also VMware's Infrastructure Partner of the Year back in 2012. That's out of 19,000 U.S. partners, so it was a pretty big award for us. We're also a large Microsoft partner, so when you talk about Hyperconverged, you're talking about virtualization, and we know not only the platform, but also the operating systems and the environment that run on them, and these are just some of our other awards. With that, I'm going to turn it right over here to Andy and let him walk you through what Cisco has come up with in the Hyperconverged market, and I think you'll see that they really have a compelling story for you guys to take a look at. Andy?
Great. Thank you, Kevin. So good afternoon, everyone. As Kevin said, I'm the product sales specialist for Cisco and for Hyperconvergence. My sole job is just around Hyperconvergence and really around HyperFlex, right, the new offering from Cisco. So with that, what I want to do today is I'm going to kind of just talk about some market trends, what's kind of happened the past 3 to 5 years, how the first generation Hyperconverged kind of came to the marketplace, and then kind of jump into that second generation Hyperconvergence. And then as far as the HX portion of this, I want to keep it somewhat high level, but what I'm going to do is I'm going to talk about some architectural key differences versus the rest of the marketplace, right? Because there are a lot of players out there, there's a lot of noise, and one of the things I want to talk about really is, is those architectural differences too. So with that being said, after I talk about those differences, I'm going to have a couple more points around, some of the innate features as well inside the system, and then we can wrap it up with some questions and answers from there. So real quick, I want to talk about, like I said, just the market in general, okay? Let's talk about the converged market, the one on the left-hand side, right, that integrated infrastructure, and then also hyperconvergence. So just to level us up, the integrated infrastructure or the converged infrastructure, this has been around for several years, right? This is the V-blocks, the flex pods, the smart stacks, whatever they may be, right? And they really kind of came about because what we were looking at was bringing best-of-breed hardware together to solve business problems. So we're taking best-of-breed switching, we're taking best-of-breed compute, and we're taking best-of-breed storage, wrapping all those together, making it a turnkey solution so that we can take these business-critical applications and let them reside there, right? We know it's, since we've got these high-end solutions, we can put the mission-critical apps there. They are validated designs. Also, it's the building block behind a lot of the other infrastructure as well. So we were doing this, like I said, for 5+ years, putting a lot of our applications out there. But also, this is usually some very high cost of goods as well. So it became so easy that we're sort of putting a lot of just regular business applications out there as well, when maybe we didn't need to. And we start looking at hyperconvergence, right? So hyperconvergence has actually been around for about 5 years, if not more as well. I remember looking at some of the earlier players about 5 years ago, but really it started to kind of bubble up in the past 18 to 24 months. And the whole idea around hyperconvergence is taking my compute and my storage and then wrapping it together with a virtualization layer, right? Kind of marry those pieces together so you've got one total solution versus on the integrated infrastructure side, I've got 3 different products, but I'm putting those together, where the hyperconvergence is really just one product, but being wrapped together with software. And hyperconvergence really took a large increase in the market because of cost and simplicity, right? We want that cloud-like economics of cost and also the simplicity of simplifying our data centers as well. So we see the adoption of hyperconvergence really start taking off more and more because what we realize is that we've got some of these applications living on our integrated infrastructure or our converged infrastructure where we can actually move those over to the hyperconverged infrastructure, lower those cost of goods on that integrated infrastructure, and then put it over on hyperconverged. And we can do that because the way that hyperconverged can be deployed so easily and the fact that it's making everything simple as well, right, and intuitive UI. So that's kind of the marketplace as far as what we're looking at right now. We've got the converged and the hyperconverged. There is some overlap there, but also we're seeing a lot of workloads now that used to live on that integrated infrastructure to now move over to the hyperconverged infrastructure. So as we start dropping into the hyperconverged infrastructure, next slide, we start looking at, who's kind of the first to market? What is that first generation of hyperconvergence? And the first generation of hyperconvergence was really 2 things, right? Get me to the market as quickly as possible. And I'm not going to name drop during this conversation, but I'm sure there's, we're all in the industry, so I'm sure you can know where I'm going with that. But be to the market first and make it very simple. That was the whole idea around hyperconvergence as the first enter the marketplace, and it worked, right? I mean, some of the earlier companies really kind of paved the way for hyperconvergence, and that's why Cisco is getting into the space as well, because there is such a major demand for that. And what I want to talk about now is as Cisco's getting into that marketplace, everyone says, well, you guys are late. Well, it's not necessarily that we were late, it's that we really took our time getting in the marketplace. Next slide, and you start looking at UCS as well, right? And UCS wasn't the first into the marketplace, but you saw the time that we took from the engineering side to make a very robust and strong platform. It's the same thing we're doing with HyperFlex as well. So, with taking our time and getting into the marketplace, hindsight's always 20/20. And with that being said, we can take a step back and say what was done very well and what are some things that we can improve upon. And we can call them gaps, right? What are some of the gaps in hyperconvergence between this and the next generation? And what we saw was that so the first generation of hyperconverged platforms is they actually introduced a new silo. And what I mean by that is, for years we've been trying to kind of shrink our footprint in the data center by consolidating different technologies, one pane of glass, and so forth. So we used to have our storage folks, our virtualization folks, our networking folks, and the converged infrastructure helped a lot to bring those together. Well, now with hyperconvergence, if we're introducing another silo, we kind of step outside that. And that was one of the things that we looked at, we wanted to address. We wanted to make sure that all the manageability and all the administration was done inside an existing tool today, instead of having to learn a whole other platform. Okay, so you'll see how we talk about our integration side of vCenter. The next thing we look at is inefficient scaling and data optimization. So I mentioned earlier at the very beginning where that was, go back one more if you could. We talked about architectural differences, right? And we're going to spend a lot of time on these pieces because the foundational differences between HyperFlex and what the marketplace is doing is allowing us to scale differently and allowing us to look at advanced data services and data optimization as well. And then finally, the thing that we looked at too is that there was no network included, okay? And I use the analogy that one of my colleagues used that I've stolen from him, but it's a great analogy. If I give you an island in the Caribbean, you still have to have a boat or a jet to get there. If I give you hyperconvergence, if I take compute and storage and wrap it with a virtualization layer, I still have to have a network to get to that new technology, right? Well, Cisco being the foundation of networking, we want to make sure that we're including that networking, okay? And there's a couple things why it's so important that we include that networking. One is management, okay? It's the same standard management that we know and love inside of UCS around UCS Manager and the Fabric Interconnect. But then also the bigger part is really around the performance, right? If I have to have networking anyway, and if I put in my hyperconverged solution and I use my traditional LAN and my 10 gig networking, I'm taking up bandwidth and I'm also increasing my latency as well. So with us and the hyperconverged solution, all of our traffic stays southbound, and we'll talk more about that as well, but it really increases our bandwidth and lowers our latency, right, which is exactly what you want when we're talking about moving some applications around. So networking was really important. So these were some of the gaps that we looked at to really go into that now that next generation hyperconvergence, right, that second generation hyperconvergence. Next slide. And once again, it's about keeping things simple. So you're going to see us talk about vCenter, the integration side of vCenter. You know, let's get rid of that other management silo. We're going to look at the simplicity as far as vCenter, and then integration inside the larger existing data center and UCS data center as well. So keep in mind, right, so this is part of the overall Cisco portfolio. It's not everything, right? We don't only just sell hyperconvergence. So with that being said, we look at solution sets in data center and say, you know, where is this a good fit, where is it not a good fit? If all I sold was hyperconvergence, then everything is a nail and I'm a hammer, right? And that's not the case with Cisco, because we do have a larger portfolio inside the data center, and we can say, you know, and be more strategic and say, you know, these applications should live on hyperconverged, and these applications should not. So that integration inside the larger UCS data center as well is key. And then making sure that we're scaling and being resource efficient. We're going to spend some more time at this throughout the rest of the discussion, but really looking at the way that we can scale versus what the marketplace can. And because it's one of those things where, you know, for years we told applications how to scale. And what I mean there is that if an application says, I need more memory, well, in a hyperconverged world, I'm giving memory, compute, and storage. But I don't need the storage. Well, too bad that's what you're getting, right? Or vice versa. What if I got an application that just needs storage but not any more memory or in compute? Well, too bad. In the traditional hyperconverged world, you're getting compute and memory as well. So as we go through this, you'll see how I kind of lay out the scaling side, but we scale a lot differently as well. And then being resource efficient. We want to utilize all the resources across our entire cluster set, okay? Not just the resources from one individual node, but the entire cluster set. So we'll talk more about that. And then finally, looking at, you know, existing applications and next generation. Since this was in the process of being built 3 years ago, and it's taken us 3 years to build this and bring this to the marketplace, right? And this really is different because it's one of those things where we wanted to engineer it correctly, foundationally different from the ground up. Build our own log structure file system. Not take a file system that's existing out there today, kind of wiping it off and putting some goodies on there. That's all fine and good, but we wanted to build ours from the ground up. Find that cornerstone of the foundation a lot different. So as we started to build it, we wanted to obviously make sure that it was adaptable as well. So it was built starting 3 years ago for yesterday's applications, today's, and obviously tomorrow's as well. And the reason I can say that is because that's our foundation. It's not like we've got to break down that log structure file system, add a piece here, add a piece there. Is the foundational difference between how we're able to address multiple and myriad different of applications and next generation applications as well. So that's kind of the next generation of hyperconvergence, and that's what brings us into HyperFlex. So as you look at the next slide, you can see where HyperFlex sits in the overall Cisco portfolio. So nothing's changing inside of our portfolio as far as existing technologies, right? The Mini's still around, the fourth generation UCS, the Blade, the C-Series, converged infrastructure, right? Like I said, that's not going anywhere because there are still a lot of use cases that need to live on that converged infrastructure. And we've got some great storage partners there. We have the scale-out model on the right-hand side too, right? With big data, with large storage footprints as well. But what we realized is that we had a gap, and that was around the hyper-converged system. So this was actually a request from you guys, from the customers. We played Switzerland for a long time and said, you know, we'll partner with them, or we partner with somebody else. But this is Cisco's first and truly validated solution going out there to the marketplace with full end-to-end Cisco BU involvement, support, and everything else, right? So it's part of the overall portfolio inside of the larger Cisco platform. So as we kind of start going further into the presentation, I want to kind of tell a quick story. Next slide. And it's a quick story as far as like how we're building it out, right? And we can see the pretty picture here of the HyperFlex systems, 220s or 240s. We'll talk more about that as well. But so that's basically what it looks like. But the underpinning of it is the traditional UCS gear that's been around for 7 years, right? We just celebrated our 7th birthday. So it's the fabric interconnects that have been around for several years. It's the same UCS platform that's been around for several years. Nothing's changing there, and we're taking a virtualization layer with VMware ESX, wrapping that together, marrying now all 3 of those components. As I mentioned, traditional hyperconverged is compute and storage married together with some virtualization and software. We're taking networking, compute, storage, marrying those together with the virtualization package, and then on top of that, we're laying on the HX data platform. And that HX data platform, next slide, is the, like I said, it's that log structured file system I've been talking about, right? This is the core foundational difference between what we're doing and what the industry is doing, okay? We built this from the ground up, like I said, 3 years ago. And in doing so, we looked at things that the traditional hyperconverged players today really can't accomplish without some performance penalties. And one of those key things is deduplication and compression. So ours is always turned on with no performance impact, okay? We're able to have these advanced data services because of the way we built this log structured file system. The way we do snapshots is innately different as well because of the fact that this was built from the ground up and looking at, you know, this file system differently than the traditional virtualization file system, okay? So this HX data platform, this is really, you know, the piece that makes everything else different, okay? The HX data platform on top of traditional UCS gear that's been around, that's been tested and validated with the virtualization layer, all those pieces come together, and then you'll see integration inside, next slide, of the larger UCS portfolio as well, right? It's part of the strategy. So you'll see integration inside of ACI. You'll see integration inside of Cisco Security and Cisco Enterprise Cloud Suite as well, right? It's part of the bigger data center portfolio. So that's the introduction of HX Data Platform, that next generation of hyperconvergence out there, and how we're bringing it to the marketplace. So you can go and build this out. So here is where I'm going to tell a quick story, okay? There's a lot of words in this slide, but really it's about the story behind it. So anytime that we look at hyperconvergence, there's 3 things that we really care about and why we're adopting it inside of our infrastructure. A, it's simple. That's the whole idea around hyperconvergence. Make sure it's very simple, and make sure that it performs well also. If I'm looking to take applications from a converged infrastructure or maybe a bare metal or something else and move it over to my hyperconverged infrastructure, I better perform as well, if not better. So performance is key for hyperconvergence as well. And then finally, resiliency. It's all fine and good if I make something really simple and easy to use and performs well, but if there's a failure and I lose data, that's a serious issue, right? And we're not playing in the data center anymore. So these are 3 big things. And I lay these out, really the 3 pillars really of hyperconvergence in general. But I lay these out because I'm going to tell a story quickly about an early access program that we had. And it was, we actually started this last year. And I was working with this one customer, and it's a large enterprise customer, and they, I was working with for a year before that as well, but, you know, looking at their data center, different projects that he wanted to initiate inside the data center. And really he wanted to kind of build his own internal cloud, okay? But he wanted to be able to control it himself. And like I said, in the converged infrastructure world, you know, we still have some storage silos, we still have some networking and so forth. He wanted to really kind of bring all that together. So as this product became more and more prevalent inside of the internal Cisco, I reached out to him and I said, hey, Mark, you know, I've got an idea here that, you know, something we talked about a year ago, this might be a good fit for it as well. What do you say you give it a shot? And he said, yeah, sure, Andy, that's fine. Let's bring it on site. Let's try it out. So we brought it on site late last year, got all the gear stood up. We trained the team in about 20, 25 minutes because it's all done through vCenter. Everything we're working on is being done through vCenter. So if you're familiar with vCenter and you're in there day in, day out, we can train you in 20, 25 minutes. We got the team all trained up, ready to go. And then we walked away and we said, all right, you know, you guys hammer away on it, take your time, you know, run your tests, whatever you want to do. So we'd have these touch point calls and so forth every, you know, 7 to 10 days. And the first thing they're looking at was performance. So we sent them a 4-node cluster, and we sent them a 4-node 220 cluster. What that is the 220s is the model where it's a 1U pizza box. So we sent them 4 of those with 2 fabric interconnects, okay, so a total of 6 U's. So in this 4-node cluster, these 4 220s, they started running these performance tests, right? We all know that the standard performance tests out there, they had a couple ones that they had built themselves as well. But we were seeing between 60, 75, and 80,000 I/O. I was like, all right, that's pretty good. They were kind of surprised as well. You know, I will say this: we are not an all-flash array, and this is being recorded, so I want to make sure we can go back to this as well. We are not an all-flash array, so we don't have microsecond response time, but we have very low millisecond response time, right? So we saw some very good I/O and saw some good response times as well. We even dig a little bit deeper, and I find out that the same performance test they had run against their all-flash arrays, all 3 of the big names out there today, they ran the same performance tests against us, and we passed all those. Once again, still not the same latency, but still very strong performance, okay? And this was in a 4-node cluster that they run this on. So I was pleased. I was like, all right, that's good to hear. That's some good performance, especially from stuff that we're seeing outside the lab, right? We're seeing this now actually at the customer site as well, at your data center. And the next thing was resiliency. He said, all right, Andy, you know, we finished with the performance testing, but now I'm going to tell my guys to go and break the system. And he said, I'm going to let you know we're going to be malicious about it, and we're going to try to break it. I said, that's fine. That's what we want to see, right? Because we've been doing this now, you know, kind of in stealth in the past 3 years, building this from the ground up, and our QA engineers and our engineering can only do so much on the back end to really test this, at least from their perspective. We want to see what customers can do too. So as data was being written to this 4-node cluster, engineers went up to it, pulled the power on 2 of the nodes, went to the other 2 nodes and pulled a hard drive in each one, at which point the cluster will go into a failed read-only state as designed, right? We don't want to make sure, that we're not going to lose any data or have a split brain problem. So that's fine. And now the next question is, let's get TAC on the line and see what happens. So we get TAC on the line, Cisco TAC, and then within 25 minutes after bringing everything back up, every single VM spun back up, no data loss, no data corruption, nothing lost, right? This is the point where my customer looks at me and says, you know what, Andy, all right, works as designed, very solid product. And I was like, great, that's fantastic. And in the back of my mind also, it says, you know what, that 3 years that we spent, when I hear all this market noise saying, hey, they relate to the market and so forth, no, it was 3 years spent doing the right thing, making sure that we're engineering it the right way before we release it, okay? And those tests, the fact that the simplicity, the performance, and ultimately the resiliency test that they ran shows that we did it the right way. Yeah, maybe we weren't for the first to market, but I'll tell you what, with the traction that we've got now, it'll be really interesting to see where HyperFlex goes. So, like I said, just a quick story I want to kind of throw out there, and we'll start kind of diving into it a little bit more now.
Hey, Andy, it's Kevin. We got a couple questions here. One from Joe that says, I heard a 4-node configuration. Is there a minimum number of nodes that you need for your HyperFlex?
Yeah, great question.
Okay.
Yep. So the minimum number of nodes today is 3, and we scale up to 8 today, right? And when I say today, I'm prefacing this because as we went to first customer ship, went to market, we wanted to make sure that we were validating certain configurations. You'll see that number change from 8 and grow substantially. You'll actually see it double here within the end of the year. Okay, it's just a matter of what we're validating today. So a minimum number is 3. It's 3 220s or 3 240s, and then up to 8 of those nodes today.
All right, and then Sydney asked, if I add more nodes, do I add more disk performance?
Yes, and we'll talk a little bit more about that, and we'll talk about the additional. That's kind of I kind of want to hold that one a little bit, so when we get to the scaling conversation. But in short, yes, we do. Every time we add a node, we're not only adding capacity, but we're also adding performance. But there's different ways that we can do that too. Okay. And guys, just keep your questions coming. We'll try to hit Andy with them as they come in, as it's pertinent to his presentation. You want the next slide, Andy? Yes, please. So I'm going to talk about some of the use cases real quick. So virtual desktop, I tell my customers that this is a really easy one. Everyone says, well, Andy, what do you mean by it's easy? VDI is not necessarily easy, and that's why we see a lot of the adoption has failed. Well, I mean, I used to sell Flash way back in the day, and you know, when we used to deploy VDI deployments, you know, we'd go and carve or look at the total number of users that we're going to potentially have. Right, let's call it 2,000 users. And then we go and buy this big frame of storage with some flash in here, or maybe an all-flash array we'll see, or a couple of them, and then we eventually grow into that over time, right? It's like here's 150 users here, another 150 here, 500 here, whatever it may be. So the way that we scale, the way that we can add, and you'll see as this becomes more prevalent as I talk about the scaling solution, as we continue to add additional nodes or compute or things of that nature, we can really scale around that application. It goes back to that story again, right? Let the application tell it how it wants to scale versus us tell the application. So the way we can predictably scale and uniquely scale throughout that HyperFlex environment makes VDI a very interesting workload for us. Server virtualization. You know, depending upon who you are, you may be 70% virtualized, you may be 95% virtualized. But a lot of those applications, those business applications, might be living on that converged infrastructure, right? So let's take some of those use cases, some of those workloads, move them over to the hyper-converged solution, free up some of those more expensive cost of goods, and let it live over on hyper-convergence. And we feel comfortable with that as well because of our performance, the way that we can perform in a lower latency, high I/O environment, and also our resiliency too, the way we can handle multiple different failures inside of a cluster and still continue to function, right? So we want some of those workloads over here. And then test and development. I also would like to rename this, you know, application development or maybe even internal cloud. And I'll say this, and I'll explain it this way. So everyone says test and dev, right? I can do all kinds of stuff in test and dev. If you're an application developer, that's mission critical because that's where you're doing all your work, right? And this is one of the use cases where I was talking about the customer that brought it on site in late December was really interested in because his end users, his developers, right, his customers would come to him and say, hey, I need, you know, X amount of virtual servers for dev, for test, for beta, for pre-prod, whatever it may be, and I need them today, right? Well, he'd have to go and scurry and, you know, more like a week and a half to 2 weeks where he could get all those VMs and send them out to his end users. Where, or if in the case where, you know, that's not fast enough, then what we see is a lot of proliferation of shadow IT, right? Where fine, I'll just go to AWS or Azure, swipe my credit card, and I'll spin up the VMs just like that, right? And good to go. Now I can go and do my work, what I'm supposed to do. Well, with our technology and like that log structure policy that I mentioned, we have the ability to do some rapid provisioning as well, some rapid clone provisioning and snapshotting. This is built into the technology. So we can actually spin up 25, 50, 100 different virtual servers powered on IPs, everything else within a minute, right? So what my customer was looking at doing was basically, like I said, providing an internal cloud and be able to spin up and spin down virtual servers at a moment's notice, so he could answer them for his end users as well, right? So it's a test dev, application developer type of scenario there for a use case. And then lastly is the large remote branch office, or a ROBO, as some people refer to it. The fact that we're including our networking as well, right? It's more of a kind of drop it off and as an appliance type of mode, and then come back and administer it all through the same vCenter that you're used to working on day in, day out, right? We talked about our resiliency. So the fact that we can handle multiple failures inside of a cluster means that if something were to happen, that remote site is still up and working and gives enough time for a driver, replace the whatever it may be, right? So it allows us to really simplify that deployment into the remote site.
Hey,
so these are some of the use cases that we're looking at today. Yes.
I got another question from Sam, and Sam wanted to know, he owns UCS's today, and he wanted to know if there's any incentives to do an upgrade to HyperFlex, and also would it include maybe even buying back any of his VNX storage or any of his other storage solutions? Just a question from Sam.
Sure. There are no programs today for buybacks. I will say this. We have discounted the HyperFlex bundles in technology significantly. Where for in years past, everyone's been known to be paying a premium for Cisco gear. We are the most aggressive in the marketplace today against any other hyper-converged manufacturer. I can say that without doubt, because I've seen all the other quotes and I've seen us quote out and beat every single one. So to answer your question, I know I kind of skirted some of it. There's no official buyback program. I've done some creative things inside of deals to basically offset maybe some other purchases as well. So I'll leave you with this. In the realm of HyperFlex, nothing is really off the table. So get with Champion after the call, and we can get on a separate call, and we can get very creative. And my business unit is in the business of being creative to answer problems like that. Okay, so no official programs. Like I said, we can always do some interesting things.
Great answer. Okay.
Yep. Okay, next slide. You can just build this one out if you want to. There's 4 sections here. So here's just a quick picture of it, right? 4 different things. We're going to talk about, I'm going to dive in deeper here in a minute, talk about scaling and the scale architecture. We're going to talk about also some of the, near the end of the conversation, talk about some of the features themselves, right? And like I said, that's a piece up to itself. That's a feature piece. Core foundational differences, right, is what we're going to spend most of our time on today. Enterprise data protection, I kind of talked about the resiliency so far, right? I've not talked about the call home function, but I'll address that near the end as well. But the way that we can self-heal, we can do rolling upgrades without any disruption as well. And then finally, we're going to talk about single point of management as well. Today, everything is integrated inside of vCenter. Every piece of, I mean, it's so integrated inside of vCenter. I was just doing a proof of concept with a customer in Tampa, and at first, like we get it stood up and walk away and so forth, and I had a call with him. Like, so how are things going? He's like, honestly, the first couple of days I was a little confused, and I said, well, why is that? He goes, I didn't know where to go to look for stuff. Like he was looking for another management type pane, like everyone else has. And then he said he realized, and he kind of felt dumb afterwards because he's like Andy, everything was right there inside of vCenter. I create a data store the same way. I mean, it's almost to the point where HyperFlex, you don't even realize that it's running on the back end because it's all inside of vCenter, minus just a couple other license plates that we have in there, but it's all right there, right? So that's, and when he said that, it was great because that actually kind of tells our story even more, how simple it is, the integration inside of vCenter. Okay, let's go move on from here. Let's start jumping into the actual, like I said, core foundational differences, okay? So we're going to talk about some dynamic data distribution, okay? The counter to this would be what's considered a data locality, okay? And data locality is a term out there in the marketplace today that a lot of our vendors use and rely on. And really what that means is that I'm going to be using the resources from one single node and one single node alone. So as we're looking at this one slide right here, what's happening is that, and this is the traditional hyperconverged infrastructure right here, okay? So data comes in to my first node. I have to replicate or mirror that data to my other nodes. This is just how hyperconvergence works. Make sure that I have a copy of my data in case something were to happen. Okay, this is like this is looking at being when I'm talking about being resource efficient. You'll see how we're different here. So data's coming into my traditional hyperconverged node. The controllers, they're moving to the other ones as well, making sure I've got my copies. After that, that machine on the left-hand side is the one that's doing all the work. Okay, so it has the workloads there, and is the one who is doing all the processing, using all the memory, and then on top of that too, also utilizing just the traditional spindles and flash on that one node. Okay, all I'm using is the resources from this one node. So the concern here is, let's say I've got a VM that gets a little squirrely. Okay, it's a little squirrely, so it's taking more and more I/O, more and more memory, more and more processor than it should be. Well, the counter to that is it's going to start affecting other VMs that live on there as well, right? This is also where you can start introducing hotspots. So I've got this VM that's utilizing more resources. I'm tied to the capacity of that one node as well. I can't grow past that one node. I can't get more SSD in that node as well. I'm only accessing the actual flash and the magnetic media that live on that drive. Okay, I've got replica copies over on the right-hand side in case something were to happen, but I'm only using the resource from that one, and that's what's considered data locality. Okay, sometimes we can have a big whiteboard discussion, down the road, in each other's offices, but this is one of the core foundational differences that we're looking at. Next slide. And we said, we don't want to subscribe to data locality. We want to look at a truly dynamic data distribution. Okay, so this looks very familiar like the last slide, 4 nodes here. The difference here is that as data is coming in and being replicated across to the other nodes and the actual data itself is living there, we introduce that HX data platform. And what we're doing now is we're saying that that every single node in the system is participating as one larger cluster. Okay, introduce the HX data platform, and now I'm taking the magnetic media, my spindles, from every single one of my nodes, from 3 nodes up to 8, up to basically 62 terabytes worth of capacity, and I'm pooling it into one large data store if I want to. Where in the old way, I only have a data store as big as that one single node. Now I can make my data store massive. I can utilize all my resources across the entire cluster, right? The old way is almost kind of like that active-passive way that we used to have to acquire hardware, right? We always wanted the passive one there in case something were to happen, but we're always kind of, hitting ourselves in the leg because we couldn't utilize it, right? It was just in the CYA machine, right? Where we said, let's get away from that. We've built this log structure file system as a core difference, architectural difference, not just a feature, but an architectural difference. With that being said, let's utilize all the resources. So now I can build a data store up to 62 terabytes, and then the kicker on top of this too is now my flash pool is massive. I can scale my flash up to 13 terabytes worth of flash in an 8-node cluster. The old way, I had the flash of that one single node, and that's it. Now I've got 13 terabytes worth of flash. So when I mentioned some of those performance numbers earlier, it kind of resonates now, right? Because the reason we are so fast, with deduping compression turned on all the time, don't forget about that, is that we have all that flash. Our flash pool is significant. So now I've got VMs living everywhere. I can do vMotions. I don't have to worry about a storage vMotion. You'll see that here shortly. I can VM a server from one to another because, once again, I've got all my storage. And then remember, too, then the argument I always hear back is, yeah, but you're not going to be as fast. Remember, we own the network. All of my traffic right now is southbound. I'm never going northbound until I go to answer that request. So all my traffic here is southbound, running across RFIs. So we've actually done the math. It's actually as fast, if not faster, than it is on data locality as well. So once again, different architectural way of us looking at data distribution versus what the traditional marketplace is looking at. So Kevin, if there's no questions here, let's talk about scaling. Okay. So this is just your traditional hyperconverged platform, right? 3 nodes. As I've come and talking about in the past as well, if we want additional capacity or compute, I'm always having to drop in just a whole other node, right? What if I don't want additional capacity? Well, you're still getting another node. What if I just want capacity? You can press next, Kevin. What if I just want capacity? Well, in the hyperconverged world, what we just did is you're going to see as this builds out. Actually, you know what, Kevin? Go ahead and build it all the way out for us, and we can just talk about it. So we scale in 3 different ways, okay? So the first one is adding, and I'm hoping answering the question from earlier. We can add spindle and cache inside the nodes as well. So think about this. So let's say I have an application that requires 500 gig worth of capacity, but I only have 420 gigs left. Well, in the traditional hyperconverged world, what do I have to do? I'm adding a whole other node. In the HyperFlex world, I can answer the cost of that application, the cost of a few hard drives. Hard drive in this one, this one, this one, bam, I just extended my cluster. Because I can go from 11 drives up to 23 drives in my C240. That's the 2U form factor. So from 11 drives up to 23 drives in there. So I can scale my capacity east and west inside of my nodes. Can't be done other places, okay? Now, we can, and at the same token, with that, as we add additional spindles, obviously, we get the aggregate of that performance too. And then, really, where we're adding more performance also is actually adding that additional flash. I'm making my flash pool bigger as well, okay? And then the next one is, we can scale like everyone else, the traditional compute and storage together. But the next way that we're scaling, now this is kind of groundbreaking out there, is we can scale compute only, okay? And what I mean by that is, I can take, we just released this as well, or one of these pieces. I could take a B200 M4 blade in an existing chassis, just sitting there, have it plugged up into my FIs, throw up what's on there called an IO visor. This is part of the technology of HyperFlex. And this is when we start talking about IO visors and so forth, this is where myself and my SEs will come on site and we'll do a whiteboard discussion, but high level. IO visor is basically like a little routing engine. It's part of the HyperFlex data platform, okay? Throw that little IO visor on there. No licensing, nothing like that, but throw that IO visor on there, and now that blade can actually participate in my HX cluster, okay? So take a step back. We always have dedupe and compression turned on. There's a very high likelihood that I may have some stranded storage, right? Because I'm running out of compute. Well, I don't want to add any more storage if all I need is compute and memory. So add in a blade. They join the cluster. Now that blade has access to all the storage in that cluster. You can continue to build that out, Kevin. There's one more piece. So we can scale up to, the question came up earlier as far as scaling. I didn't want to get past this yet, but so we can do up to 8 compute and storage nodes, and up to 4 compute-only nodes. So we can have a cluster size the size of 12 nodes now. And the other thing that we just released is I can have a C220 now as a compute-only node as well. So I've got a C220 or a B200 M4 blade as compute-only nodes. So I can have a total of 8 240s with 4 nodes, making it a total of 12 today. And like I said, in the next release, you'll see that number is going to go from 8 to 16 and from 4 to 8, right, as far as the compute-only nodes. So you'll see that grow as well. Again, this is only possible, this type of scale and this type of growth is only possible because we know the log structure file system. It wasn't something that we took off the shelf that we have to bend our hyperconverged rules around. Hyperconvergent bends around us because of the fact that we built this from the ground up. Okay, so scaling is that is one of those key pillars as far as different architectural differences in the marketplace.
So Andy, let me ask you a question, and this is really me asking. You're telling me that each node doesn't have to be identical. So with most of these hyper-converged solutions, you have to add exactly the same thing that you have in all the other nodes every single time. With yours, you can just add storage when you need it or compute when you need it, and you don't have to mess around with the other nodes at the same time.
So that's a yes and no, right? So if I'm adding storage to one, I want to add it to all of them because I do want that to be uniform, but I can add individual compute that would be spec'd out differently than anything else as well. Like so my compute-only blades don't have to match the same spec as far as memory and processor that lives on everything else. I can have those independent of themselves.
Okay. I was a little confused, so I wanted to just make sure I understood. Maybe somebody else out there was the same way.
No, I appreciate the question, Kevin.
All right, next one.
Yes, please. So these are just some visuals, okay, about some of the stuff that we're talking about. And this is usually where, like I said, we get them in front of a whiteboard and at least we're kind of drawing up the file system and so forth. But I want to leave you with a couple of visuals. So here I've got a 3-node system. You can go one slide up. I've got a VM, this green VM that lives on the left-hand side, and I'm taking this data and I'm chunking it, right? This BMDK, I'm chunking it up into every single one of these nodes. Once again, not creating a hotspot, utilizing it across all of them. The same thing with this orange VM as well. VM is there. Once again, I'm not pinning everything to the left-hand one, spreading that load, making sure I'm utilizing all of them. And now this purple one, before we go any further, look at this one. So this VM right here is bigger than the sum of its parts, right? I can't fit that VM into any one of them. So in the traditional hyperconverged world, what I'd have to do is I'd have to do a storage vMotion of the orange one over here or something like that. Now I'm kind of unequal and so forth. But since we're utilizing the entire data store, right, every single cluster, it's called a bin packing process. I can take this VM and I can break it up and I can say 50 gigs is going to live on the first one, 50 gigs is going to live on the second one, and 50 gigs is going to live on the third one. You can see that in the next slide, right? So I'm breaking that up across all of them. And then once I have that VM broken up, right, balanced space utilization, one more slide, and then I can move that VM over there. Once again, look what I just did. There's no storage vMotion whatsoever on the back end because I got data over there already, right? I don't increase that network traffic across those different hypervisors, across that cluster, which will also leave a lot less stress on the network as well. Okay? So just a quick visual for some of the stuff that we've been talking about so far today.
So I got another question for you, Andy. This comes from Thomas, and I think I know the answer, but I'm going to let you answer it. Will it work with any storage or compute other than UCS?
It's a very good question, and the answer today is it's only validated and running on UCS. There's discussions to, well, it will only ever run on UCS, but there's discussions to see if we can just do software only and not have to have it actually on a specific HX node. But today it is UCS only, and that is for the foreseeable future.
Okie doke.
Okay. So this next slide, there's a lot going on in it, and it's really cool because it kind of explains how we handle. It says non-destructive operations. So this is how we handle failures, how we handle software upgrades, how we handle the addition of nodes as well. Let's build out a couple clicks here. So we've got a BMDK. You can see I take that data set. I'm going to stripe it across all the different nodes. So A goes to 1, B goes to 1, C, and so forth. Click it again. And this is what introduces, one more time, our replication factor. Okay, and I haven't talked about this too much because this is more detailed, right? But replication factor is our way of ensuring that we never have data loss, okay? And that we always have 3 copies. I can do 2 copies worth of data. It just depends on the workload, but the preferred methodology is to have 3 copies of data. So now you can see it's kind of tough on this on here, but you can see I've got my my data replicated across all the different nodes. I've got A1 on the first node, on the second one I believe it is, and the third one. So I've got 3 different chunks of data, and the same thing goes with everything else as well. As we look at this next slide as it builds out, if we were to lose an entire node, what happens, right? So VMs are going to move over one more slide, right? They're going to automatically restart because it's just the HA functionality inside of VMware. Those move across. At this point, one more slide, we realize too that we always want to have that 3 copies. So this is all going on in the background. So HyperFlex says, all right, I've got 2 copies. My replication factor is 3. Let's go ahead and take those chunks and fill them back in on the other nodes to ensure I've always got a replication factor of 3. Okay. So now we're all good. There's no issues whatsoever. We're not down. We don't have any loss or corrupted data. Now the time comes to add the node back in. So as we add the node back in, you can see that the hypervisor comes up, the controller VM. This is where all of our intelligence is happening, right? The controller VM is as my engineers call it, a first-class citizen. It will be the first one to come up. Nothing else comes up before that controller VM comes up. Once that controller VM comes up, I'm going to start taking data, right? I'm going to start participating in the overall cluster. I'm not going to become a hotspot because once again we balance all of our data, but I'm going to start taking data. My SSDs will start being part of the overall flash pool, so my magnetic media. I'm starting in, like I said, becoming part of the cluster. Meanwhile, on the back end, next slide, I'm rebalancing that data all the way across, right? I said, okay, I've got a 4th node now. Let's take these chunks of data, replicate it across there. Now I'm back to 3 copies once again across all these different nodes. And what just happened there is the exact same thing that happens as we add another node, right? So I add another node into a cluster. Storage is automatically increased. On the back end, HyperFlex is saying, all right, we've got another participant in my cluster. Let's go ahead and utilize him as well. Let's get that flash in here, utilize his capacity, boom, 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 and start moving that data all in the back end. Once again, all that data movement for us, we don't care because we own the network, right? So rebalance all that data. Once again, this is how we, last slide, and this is how we also handle, like I said, the rolling software upgrades. We've got some triggers in here to say, if you're down for 15 minutes, go ahead and start this process, or, I know I'm going to be down for 15 minutes for a software upgrade, so don't worry about the rebalancing the data. But once again, this is how we handle all those different scenarios inside of our clusters. So from a true failure, from a software upgrade, from a addition of a node, whatever it may be, on the back end, this is how all this traffic is moving back and forth. So, like I said, a high-level picture. This is, the last few slides are the ones where you can spend, an hour on a whiteboard. But any questions on this?
Yeah, James has a question. He goes, is there a certain level of VMware that you have to be running to get this functionality?
Great question. And the level of functionality for this is, I believe we just certified standard for this. So prior to that, it was Enterprise and Enterprise Plus, but I believe we've just certified standard for this.
All right, that's the only question I have.
Okay. We can move on. So here, the last few slides, we're going to end right on time too. Everything we just talked about up to this point was architectural differences and foundational differences that we have, and all in part because of the log structure file system, right? So these are some of the features that we get benefits from that log structure file system. All of our snapshots are pointer-based. This GUI that you're seeing right here would be inside of the vCenter as well. The reason we're a little bit different is that we do not have the same performance constraints that traditional VMware does, right? They want 3 or so snapshots because the redo log gets too big, performance issues. And when you do a traditional snapshot of VMware, it's taking a full snapshot. If you got a machine that's 45 gigs, it's doing a 45 gig snapshot, or bigger, right? All of ours are pointer. We do one initial one, and that happens out of the gate without you guys really even knowing it. And then after that, it's all pointer-based. So with that being said, we can basically hold an infinite amount of snapshots. We actually have customers that buy this just for some of the snapshotting technology. It's funny, one of the authors of our software, he was an old VMware guy, and he wrote BMFS, and we kind of joke with him like, we're having to fix some of the problems that you built, 10, 15 years ago with BMFS. We're now with the HX data platform, we're getting around some of those bottlenecks, right? So all pointer based, all this is inside of vCenter as well. When you actually go inside of vCenter and say, do a snapshot, it's actually on the back end. It's using our technology, even though it's going to look like it's truly through just the traditional VMware one, but it's using our technology on the back end. So pretty cool there. Next slide. So I believe, yeah, this is the rapid provisioning. Something else that I mentioned earlier on as far as the use case, and spinning up 25, 50, 100 different VMs in a very rapid time frame. So something else that we added, it's good for some use cases, and for others we don't need it. But I can spin up, like we said, 25, 50, 100 VMs, powered on, custom specification. All this being done because off that first snapshot, everything else is pointer based, right? So we demo this all the time, and if I had an engineer with me, he could do a demo. But we can see by the time we actually get back to the interface to actually look at the machines powered up, they're already there, and we can log in and do all of our work. So cool feature for this as well. Next slide. And then touch on this again. Once again, it's 100% vCenter-based management. Today, you'll see some announcements in the near future around some other hypervisors as well. But today, everything is vCenter-based. If you know vCenter, like I said, you'll be up and running in no time. Next slide. And support. Let's talk about, I mentioned support earlier. So if we look at hyperconverged players out there today, who owns it, right? That's what it comes down to. Who owns the whole platform? Who owns the compute and storage? Who owns the networking? Who owns the virtualization layer? All of that. When you look at what Cisco is bringing to the marketplace, you've got the compute, the storage, the networking, the virtualization layer, since we sell VMware, we support that also, and then the HX data platform. All of those pieces together, wrapped up and being supported by TAC, by one phone call. In a traditional hyperconverged world, when something happens, is it the networking? I don't know. Let's call the networking guys. Is it the hardware manufacturer? I don't know. Or is it the software? Who do we call? It's all being done through Cisco. Okay. So what we're seeing here is this is monitoring and analytics that's sent back to my TAC team every single day. Okay. So we know what's going on inside your boxes. We'll probably know before you even see an issue as well. You may get a call from saying, hey, we see your hard drive failed. We went ahead and opened a case for you. Depending upon your support contract, you'll get it in 4 hours or tomorrow, right? So instead of having to pull together all these different logs when you have to troubleshoot an issue, when a TAC engineer launches the support event, they'll have all the information there ready and waiting. And as we got 2 more slides left. Next slide is I just want to talk about some of the configurations, right, and look at some of the different nodes. I've kind of talked through this as well, but we've got the 220s that all live together, okay, underneath FIs between 3 and 8 of those. They have a maximum of 6 1.2 terabyte hard drives in there. So it's like this is, as you can see here, good for certain VDI workloads and Robo. You really get the most configurability of your HyperFlex with the 240s. Because in the 240s, we've got different ways of scaling, right? I can scale east and west inside of these guys, so from 11 up to 23 drive. Every time I add additional node, I get another 1.6 terabytes worth of flash. So my flash pool is going to be bigger on the 240 footprint versus the 220 footprint, right? So that flash pool is going to be bigger. And then also that 240 footprint will enable me to then grow into, if I need to, that hybrid type of solution, right? Where I can add additional blades, or like I said, 220 nodes as well as compute only. So different ways of scaling and looking at the solution. And then finally, on the last slide, what I want to finish up with is just kind of a quick recap, right? So the unified fabric is very important. Okay, the networking is the fact that we're able to take the networking piece out of the equation and really help with performance and help with manageability. I mean, these FIs are the same ones that are out there today. The only difference is that we actually already have pre-built. You guys are familiar with FIs and service profiles. All the service profiles here are pre-built. So it's so successful that actually that the FI BU is taking that policy of building service profiles out of the gate and putting them in existing or into new FIs as well. So networking is important because you have to have networking for hyperconvergence. But really, the scaling the data locality and local file system. Number 4, without that log structure file system that you've heard me talk about in nauseam probably today, without that, we don't get the advanced data services, so we don't get that deduplication and compression turned on without any performance issues, right? There's no special hardware acceleration card in this box. We don't take a performance hit when we have it. But with that log structure file system, that also allows us to look at data locality in different methodologies and say, we don't want to subscribe to data locality, but we want to look at dynamic data distribution, and that's going to help us to eliminate hotspots, right? And look at performance as well. And then scaling. Like I said, let's tell the application how we want to scale versus us telling the application how to scale. Let's scale storage independently. Let's scale compute independently inside these nodes. Let's do that. Let's look at the architectural differences for what we're doing. And then, it's all being done through vCenter. So when we say, near zero learning curve, there really is. It's so simple. And then I just touched on the support too. The fact that we can bring all these different technologies together and build a hyperconverged solution that is truly supported cradle to the grave through Cisco. It takes the guesswork out. It takes the guesswork out as far as how do I answer this? What happens if this happens? I've got these remote sites, are they going to be sourced appropriately for parts and so forth? We have, the largest, distribution of gear out there, so we can get to anywhere we need to. So all that being handled and wrapped up underneath Cisco, and then finally at a price that in the marketplace today is unbeatable, right? And we understand the importance of hyperconvergence, and we are the most aggressive BU and sales force out there trying to get this gear on the road. So with that, Kevin, I'm going to leave a few minutes for questions. I know we're close to the end of the time, but I want to open it up.
All right, and for those of you that want to ask a question, I know that we've been getting questions all along the way. There is a question box in your Go to My Webinar interface that you can ask questions. And I'm just going to go to the next slide to let people know that the first 5 requests that goes to Tim Cullen, and Tim is he owns the Cisco relationship here at Champion. His address is tcullen@championsg.com. The first 5 requests for an in-person demo with Andy and the technical team along with Champion will receive a $100 Amazon gift card. So if you want to take advantage of this offer, please email Tim Cullen, and he will be more than happy to set up an appointment with Andy and his technical team and really go into deep technical information that we just didn't have time to go through on this webinar. I do not see any additional questions coming in here, Andy, but I do want to thank you for spending an hour with us today and educating us about Cisco and their really unique solution for the HyperFlex and the hyper-converged market.
Well, Kevin, I appreciate the time, and everyone that joined the call, thank you very much for your attendance and your questions.
Oh, I got 2 questions that just came in. Are there any, and this comes from Stephen, are there any plans to include VMware licensing in your package?
Yes, we can do that, absolutely.
Oh, it's already there, okay. And with the, will the webinar be available to watch? Yes, it will. We will be sending out an email with a link so that you can actually do this anywhere you want, and that's about it. So,
Kevin, this is Jay. Just wanted to add one thing on the slide that's up. There's a little bit of a spelling error, must have slipped through the grammar. So it's CHAMPION, not POION.
Oh,
just want to correct that.
All right, thanks a lot, Jay. With that, we will end the webinar and thank everyone for their time. Have a great day.